Hello students, this is lesson U1A01c. Hopefully by the end of the period you should be able to say, I can prove segments congruent. So in this video we're going to take a look at two proofs which are very similar to one another. However, it is important to understand and distinguish the differences between these two examples. And there's also one other point of distinction I want you to make between these examples that I am showing you here in this video versus in the last video. And that is, in this video, if you notice all the information that's given in the problem here, there's no numbers. There are no number values. We are just talking about segments. And you're going to find that it is actually easier to work with, at least in a statement and reason chart like this, okay, in this format. It is actually easier to work with this kind of problem where there are no numbers than it is with numbers. And you're going to see that in a moment. All right. So in this problem here, you're asked to show that WXYZ, which is are all points on a line. You're trying to show that segments WY is congruent to segment XZ, and you're told information about WX being congruent to YZ. So I've said this in a previous video, and I'm going to reiterate it again. Riddled all throughout the solutions, okay, that to the problem sets associated with this lesson, you're going to see that I use concepts to distinguish the difference between congruence versus equality. I am not going to hold you accountable to that. So what I'm going to do in this video, okay, it's going to look slightly different from that of the solutions. So recognize that you are not held accountable for those steps, okay, or having to distinguish the difference between equality versus congruence. We're going to use congruence as if it is an equal symbol. However, understanding that, you know, there is a very subtle difference, okay, between those two symbols. But for this course, moving forward, we're going to treat the congruent symbol as if it is an equal symbol. All right, so let's get to it. So what I notice right now, I have, I noticed that this segment here, which I'm going to use in red, okay, WX is congruent to YZ. That is something that's given in the problem. Nothing in the problem is telling us what the segments XY is, so it doesn't have to be the same as WX or YZ, so for that reason I'm going to put 2 tick marks. If you look at this setup right now, the length of WY has how many tick marks? It looks like there are 3, right? And if I do the same thing, okay, with XZ there, it looks like there are 3 tick marks there. So intuitively, it should make sense that both WY and XZ have the same exact length. So let's try to articulate this on paper. A strategy that I would like to tell you all is this. If you're ever told to prove anything, okay, where it involves segments, and you know certain segments is made up of other smaller segments, it would be a good idea to articulate that in the statement of reason chart. And then from there, okay, other relationships will begin to reveal itself. I promise you this, okay? So let's take a look. I know that WY is made up of WX plus XZ. Similarly, I also know that XZ is made up of XY plus YZ. Isn't that right? Okay, and this is true, okay, and it requires no prerequisite information whatsoever, okay? This is true because of the segment addition postulate. And again, this requires no logical prerequisite understanding, okay? This is just something that we can throw in because, again, like I've said, a postulate, okay, is something that we recognize as true, that this is just a logical statement that we recognize as true, all right? Now, once we get to this stage, okay, our objective is to somehow show that segments WY is congruent to XZ. So how are we going to do that? Well, if we look at XY right now, segment XY, right? Segment XY needs to be involved in our articulation. I recognize that segment XY will also be equal to itself. And again, this does not require any prerequisite understanding, but this is a standalone fact. This is because of reflexive. Okay. So remember, we're going to treat the congruent symbol just like we would treat the equal symbol. They are the same exact things. We're going to treat them like they're the same exact things. Now, watch what happens. Because I'm telling you that Wx is equal to Yz, which is set in line 2. And if you look at this, okay, I also tell you that xy is equal to xy, right? If we're treating this as if they are equal statements, as if they are as if it's an equality statement. So in other words, lines 2 and line 5, they're actually like an equation. So if we're treating this like an equation, then we can operate it, then we may operate on it as if it's an equation. So what am I suggesting here? And this is the part where it requires you to make that leap of understanding. I want you to pause the video and try to figure out, what do you think I'm going to do with lines 2 and 5? Hopefully you had some time to think about this. But what I'm going to do, if I'm treating line 2 and line 5 as if they are equations, I will add Wx and xy together. So line 2 and line 5 together. I will also add yz and xy together to get this. So this is true because of addition between line 2 and line 5. So now that I have this in place, okay, I have all this information now, okay? This is true because we've added lines 2 and line 5. Line 6 is true because we added line 2 and line 5 together. All right, now check this out. I want to highlight this in green. What was Wx plus xy equal to? Oh yeah, that's right. It's this thing right here. Wait, what was xy plus yz equal to? That's right, it's this right here. So with all that information, okay, that I have now, that's on my palette here. I think of this as a palette, right? Like an art palette. I can see that Wx plus xy, right, is really Wy. And I see that xy plus yz is really xz. And remember, I said that we're going to use the symbol equal and congruent interchangeably. And because our goal was to show that Wy is congruent to xz, I'm just going to say Wy is congruent to xz. And this is because of substitution. Which lines am I substituting to and from? I am substituting information from 3 and 4 into line 6. And there you go. So let's take a look at the second example. Again, very similar in nature. Here in this case, okay, we're reversing the order. I'm telling you that AD is the same as NY. And what we're going to do is I want you to tell me that these segments that are in green are going to be the same. See if you can convince yourself that that is going to be true. Okay? And if you can, right, let's try to assign some numbers, even though there are no numbers here, okay? But let's say if this was segment, if AD was 10, this segment here also has to be 10. If ND is 6, right, what would AN have to be? AN must be 4. And if AN is 4, well, therefore, the other segment over here, DY, it too must also be 4 because 6 plus 4 should also equal to 10. So again, you know, you should convince yourself that what you're trying to prove is actually logical. So AN and DY will in fact have the same exact length. So in order for us to articulate this on paper, we will again need to use segment addition postulate. Like I've told you before, it is always a good practice to not just draw all over the diagram, but also to indicate what different segments are made up of. So in this case, AD, I know that AD is equal to AN plus ND. I also recognize that NY is equal to ND plus DY. So because of this, and this is true, again, regardless of any other information here, so this is true because of segment addition postulate. I'm going to cheat a little bit. I'm just going to copy this because it's the same exact thing. So this is true because of segment addition postulate. If I take this, okay, information now, and now let's check this out. If I have AD is equal to this, right? And NY is equal to this. But wait a minute. I'm going to use a different color here. But wait a minute. What was AD equivalent to again? Oh yeah, AD is equivalent to NY. So what I can do then is I can perform a substitution. So I can say AN plus ND is equal to ND plus DY. This is true because of, again, substitution. Substitution of which lines? L3 and L4 into L2. What we're going to do now, if you notice, our end goal was to show that AN is the same as dy, right? Is congruent to dy. So, and if you notice, if we're treating this like an equation, right, we have the same things on both sides, I'm going to try to get rid of that. I'm going to say ND is equal to ND because of reflexive. So therefore, my last step is to subtract line 5 and line 6. I will end up with AN equal to dy. Or in other words, AN is congruent to dy. So this is true because of subtraction of lines 5 and 6. Again, I encourage you to take a look at these two examples together, side by side, and to understand the differences between these two problems, because there are going to be other problems that we are going to build off of this question. So rewind, replay, pause, and redo. I'll see you in the next video.